All right. Good afternoon, everybody. I always love getting the lunch spot because like everybody's full and sleepy. So that's awesome. My name is Kevin Myers. I'm a senior network architect with IP Architects. We're an independent consulting firm doing network engineering around the world. I've got Sajan Parikh here with me because he's my YAML translator because I am actually not a coder. I'm just a route switch guy. And so we're new to Faucet and just kind of getting into this community and understanding some of the practical applications that we could use it for in production networks. So that's what we're here to talk about. Very brief background about me. My background is in a lot of ISP focused, telco, ILEC, CLEC, large ISPs, did a little stint in Fortune 500 enterprise data center. So kind of like all around the networking space. I blog at stubberry51.net, a lot of it in white box and commodity networking. I spent a lot of time working on white box production networks with things like IP Infusion, Cumulus Linux, Edge Core boxes, Delta boxes, things like that. We really kind of like open networking. That's a big focus for us. So we spend a lot of time in that, which is why coming to Faucet was very appealing for us. You can find me on Twitter at stubberry51.net and also a contributor at thenetworkcollective.com, which is a group of network engineering geeks, techfieldday.com, and packetpushers.net. And there's my email if you want to reach out to me. And a brief overview of my company. Like I said, we're an independent consulting firm. We work pretty much all over the world. We've got an office in Europe, a couple offices in South America. We do a lot of work putting the internet into underserved and underdeveloped places. We build a lot of ISPs where there is no bandwidth. We put in fiber, microwave, and a lot of different things where there are no services. And so we've done some really interesting things in some really remote places on pretty much every continent except Antarctica. Had to fly a guy up to Alaska, about 100 miles from Russian airspace a couple months ago, putting in an ISP up there. So because their PS4 did not work well and they wanted help. So, that's a real problem. So that's, like I said, we're very open networking focused on white box and disaggregation. And that's just kind of a little bit about what we do in my day-to-day. So one of the problems that we saw for Faucet, and I'm going to go ahead and throw Nick Braulio under the bus because he's sitting right there. Nick and I are really good friends. We talk a lot on Slack. And one of the things that we always talk about is how we can get better about traffic engineering, especially on wireless networks. Wireless networks have a lot of challenges that wireline and fiber networks don't have. And especially with the advent of things like CBRS and 5G that, in fact, we just came from Las Vegas at WISPAPalooza, which is one of the largest conferences, if you're not in the LTE space, to do microwave and wireless networking. And there are a lot of things happening, and wireless is going to a lot of places that it, hasn't been before. So one of the things that we wanted to explore is, how do we get more intelligent about managing the traffic in a wireless network? And how do we take advantage of every available path as opposed to using the traditional routing protocols and MPLS and things that we've used that often leave paths unused and empty? And so that's the concept that we wanted to explore as we started working with Faucet. So let's talk about the RF traffic problem just for a little bit, something that we deal with all the time. So in a terrestrial network, you may have 100 gig paths. You may have 4 by 10 gig lag. This is very common in a small ISP. You may have some paths available. And we use things like, hopefully we don't use policy-based routing anymore, but we do. I still do see it used somewhat in traditional networking. MPLS traffic engineering, been around for a long time. We certainly do a lot of that to move traffic around and link coloring and things of that nature. Segment routing is new and hot on the scene. In fact, I was out here in Silicon Valley earlier in January talking with Cisco about SRv6 and SRv6 Plus, which is very cool. You can do a lot of things with traffic engineering in that and kind of a new evolution of MPLS. But because the paths never change, 100 gig it's either up or down. It's 100 gig available or 4 by 10 gig. Maybe we'll lose a link in the lag, but that's about the limit of what you deal with in fixed ISP networking. So if you go into a wireless network and you look at a wireless network and some of the problems that we have, bandwidth is not static. Bandwidth is this elastic thing that is constantly expanding and shrinking. And so especially as we get into things with millimeter wave that Google is into and a lot of other companies are experimenting with millimeter wave in urban areas and building mesh networks over that, one of the things that we wanted to understand is, how do we solve this challenge? Because we can have weather events, atmospheric conditions, interference, all change all of these different link speeds here. This is actually a representation of a production network that we're going to get into in just a minute that's in Amarillo, Texas. So we've got 750 meg available on this path, 300 meg on that path, 500 meg on fiber on that path, and then 1.4 gig on a licensed microwave link on that path. So you can see things are all over the board and they kind of change a little bit. So dealing with this with BGP, with an IGP, with MPLS traffic engineering is a bit of a challenge. And the LTE guys have kind of solved this. In the Metro Ethernet world, I think it's Y1731, there is an attribute to be able to kind of get that data from the radio and feed it to the router, but it's very, very limited to the LTE space. So if you're working with microwave in any other space, there really isn't a way to solve this as easily. And we already talked about MPLS and TE and segment routings. Capability problems. So looking into how do we solve this and what is a potential solution to get more intelligent about using all of the traffic. And Nick and I have been talking about Faucet for a while. And me being a traditional route switch guy, I don't get into coding much, which is why I brought Sajan with me. And we started experimenting with, what can we do? And I think it was when Northbound Networks came out with their little boxes, we started getting the idea that, hey, I could, make a little test network and see what would this look like in prod. So I think 4 or 5 months ago, I ordered a few of those things, and they've just been sitting in my lab, not really doing anything. And then Nick asked me, said, hey, do you want to go to FaucetCon? It just so happened it was the week after we were out in Vegas. I was like, yeah, that'd be really cool. So we started this idea and hatched this idea to build this this test network to do this. And so we got the Zodiac FX, which I kind of screwed up because I thought I was ordering a gig board and we ordered a 100 meg board, but we kind of blew the network up with a couple loops. So it was actually good because we only had like 10 meg loops running over the prod network. So that was awesome. And then we just needed something that we could make operational. And what was attractive to me about Faucet is not coming from a developer mindset, Faucet was very ready to run. Even with my bare bones Linux skills, we were able to get Faucet up and into operation and get it controlling switches very, very quickly. So, and I think there's a lot of people that have that story in the network engineering space. There's a lot of people out there that are traditional in the networking space, and they don't have the developer background, and they're not used to all of this and dealing with dealing with YAML and dealing with JSON and dealing with all of the developmental and coding problems. So it was a very easy transition, I think, for us to go into this. So this is kind of the concept that we came up with when we first started, is basically we started with an L2 stack, with single root, as we started looking through the documentation, do something very, very simple, and just take a VLAN from one side of the network to the other. We have the northbound boxes that we were going to use. We take basically a single customer off of the end of this network that we'll show in a minute, and just try to see if we could move traffic around with the Zodiac boxes and control it with an SDN control that we had. I think we threw it out into a hypervisor that we had in the main data center for the ISP to talk to all these. So very, very, very basic setup. And as we started looking at some of the advanced capabilities, it was really clear there were a lot of things that we could do because there was L3 available. There was BGP peering, which we hadn't even gotten into yet. And then, as I think somebody else talked about in a previous presentation about OpenVSwitch, which was great because OpenVSwitch had an appliance in GNS3. So before we even took this into prod and put these out of radio towers, we were able to take OpenVSwitch in GNS3 and build kind of a basic lab and get familiar with the components of Faucet, what a data plane ID is and how the controller interacts with that and the things that you can do as you build this out. So that was very cool, and it gave us kind of the framework to take this, into the next step to move it into a prod development. And then one of the things that was a little bit difficult and that for us to kind of figure out is like, how do we match on traffic? How do we deal with this? So we kind of kicked that around. I won't say that we have that 100% solved and want to get more elegant about it, but we started looking at just traffic source in our basic subnet that we're going to take and analyze the radio capacity with a piece that we've started developing that we're going to talk about in a minute. And basically make decisions about, do I want to use this northern path or do I want to use the southern path based on radio capacity? Everybody wins. So we had very, very simplistic concept when we started thinking about all right. What's up? Hey, that's my business partner. What's up, Derek? So anyway, we had a very simplistic concept when we were trying to decide how are we going to do this. And I think as we move forward, we'll probably look at more complex and elegant ways. But our base idea was if we're going to evaluate radio capacity and maybe slice it into 25%, 50%, 75% available, let's chop the subnet up and look at the source and then move a subset of that traffic over to another link based on what capacity we have available on another path. So we kind of split things into 26s and decided that we would try to match on source to move the traffic over to another path using an ACL for policy-based forwarding. And so here's our first shot at actually developing the YAML to do that. And we decided to go with the stack because understanding how it deals with loop prevention was something that it was kind of a learning curve for us. In faucets, we were putting the Zodiacs out to understand how that works. And we were also connecting them to some production switches, which was a little bit of a challenge as well in learning that. But basically, it was a very basic statement. Just look at, I think we looked at source 100.64.0.101 was one of the IPs that we had. Which actually lives out. Where's the dare winner? When we put this into prod, that's a dare. We actually put this out at his house, 10 miles away from where we built faucet, to put over the production network, and matched on standard Ethernet and that IP, and then did an outport to a port other than what the default forwarding path was to move the traffic, and then applied that as an inbound ACL to whatever that interface was on our first switch there, which I couldn't fit all of it on there because of sizing, But that's where we started. And I think as we read more in the documentation, I talked to Nick, I think we definitely want to move to an L3 routed stack because BGP already is running in the network, and it's something that we wanted to interface with. So I think as we look at the next iteration of this, we'll move this to a layer 3 stack with BGP. So at this point, I'm going to kind of pause because one of the things that we had to solve, which we knew that we needed to have some intelligence to tell faucet, like, how are the radio conditions changing and how do we do that? And so if you ever worked in the microwave radio world, like, things are all over the place. Nobody has the same way to grab data out of a radio. So we, have to do things like you can SSH in and scrape it, or you can use SNMP. There may be an API to go get it, or you may have to use JSON to scrape it out of the web GUI from the radio because they're all over the place. So I'm going to let Sajan talk about this a little bit about how we decided to analyze the RF environment and look at those numbers and then kind of feed that into faucet.
Hey everyone, my name is Sajan Parikh. I've been in software development for quite a while. I did large-scale Linux deployments, a lot of Python, PHP, framework development. The past few years, though, I've been working with ISPs around the world, primarily WISPs. The wireless ISPs that we're talking about here, I was with a company that managed, that ran basically a all-in-one solution, software solution that managed all these different things, network monitoring, billing, and things like that. So I've had a lot of exposure to the WISP industry and their unique challenges of like Kevin mentioned, everything being in very different ways depending on the vendor it goes. Some work over SNMP, sometimes in the same vendor, two different products will have different nibs that aren't published. And it's just hard. So in order for us to really understand how to analyze a hetero sort of environment, we needed a way to aggregate all the data, standardize it, and then be able to go through it in a way for us to influence what OpenFlow is doing on the network. And that's where Drainpipe came in. Drainpipe was a joke in the beginning because we have faucet, we have valve, and I basically needed something to put into my Git project, so we said Drainpipe. It didn't work in the beginning, so it became a joke. And then once it started becoming a little bit more real, over the last few weeks, we're like, well, we should just stick with this because it's what all the commits have, and I'm not going to rewrite all of it. So it's Drainpipe. And Drainpipe in the beginning was just, I'll be very honest, it was just a very simple hard-coded thing. Says, if this, then that, spit out some YAML. But as Kevin got a little more creative in understanding faucet and from the route switch side, it became very clear that I needed to make something that was able to handle a lot more types of data sources, standardize that data, and be able to run through very complex conditionals and influence what happens in the YAML at the end. So this is going to be slightly outdated. This is kind of our first sort of hierarchy of what we knew needed to happen from a concept standpoint. So we've got all these radios on the network. So we've got Drainpipe on the bottom left here. We're going to be feeding all this information from the network into Drainpipe. So that's going to be things like QAM, link capacities, and honestly, it could be other sources too. It doesn't have to be the radio itself. We're talking about maybe using other inventory systems out there as well, weather data to predict certain things as well. The idea is having as many data sources as we can to come up with the most accurate representation of what a particular path can and can't do, and be able to influence what faucet does. So the first thing is we get RF and path data from everyone in the network and go through all the permutations of what's possible. And then we run it through Drainpipe and calculate all these conditionals. And we basically at first started with a very base sort of configuration of this is where the best paths are, this is how everything works. And then as these conditionals are being processed, we would make certain changes in that configuration. And then at the end, whatever was left is what we spat out. No, Donald can join. That's fine. So that's where Drainpipe kind of fits into all of this. And then once it's done processing everything, we will go out and tell Faucet saying, here's the configuration that we have ended up with. And Faucet obviously does its thing, goes and spits everything out to all the OpenFlow switches out there, and traffic moves in the way that we want it to move. But that's more on Kevin's side of things. I just make the YAML and interpret that. So what this really looks like for me is this is my final return statement. So we've got, like I said, at the beginning, we were kind of building this very, small scale, but as this kind of blew up, I decided to use a real framework and actually have real data structures and start thinking about future stuff on how this will progress. And a lot of the talks that we've had, even just today, I wasn't here yesterday, I apologize, but we're talking about a lot of different people trying to influence that same YAML file. And there's Faucet Agent, of course. Faucet Agent is great if you're talking about controlling who's touching the YAML file, but there still needs to be maybe some central intelligence sort of warehouse, if you will, to process all the different changes that need to happen to come up with one final YAML. Not that we have different applications doing different things, conflicting the YAML and causing some problems. So this is the final sort of return statement. It doesn't mean anything. We're all developers here, but you can see that I just have 3 variables: ACLs, VLANs, and data planes. And the rest of the application will go through and run through its processes and essentially spit out these 3 variables. And all I do is dump a YAML. It's simple as that. But it's simple now, obviously. It wasn't simple 2 weeks ago. And, oh, yeah, my cron tab is called Drano. So I don't know if that's trademarked or not, but whatever. So Drano's command that, it's just, this is honestly just a little bash script that runs through the process, does all the calculations, restarts necessary services, and then does a bunch of sanity checks for us as well. When I run it just within my application, I am using Laravel, if anybody's familiar with that. It just offers a good web GUI as well. Or it's PHP, so it's more made for a web application. The reason I chose that is because I think that as this happens, to be able to influence the conditionals that we want people to be able to configure, that's going to have some sort of web GUI at some point anyway. So this is kind of what we're doing. So if I run plunge, I guess, to add to this, so dp:/plunge, right? Drainpipe plunge is sort of the internal artisan command that I'm running, and you can see just some basic stuff here. This is very dumbed down. This is just getting straight link capacities, and you can see that we're going to get capacity for a certain path. We're going to get a capacity for the other path, and then we'll make a decision about where we're going to send traffic towards, and that will change the output ports or the ACL in the YAML in the end. We'll go through all the risk conditionals, generate the Faucet condition, go through the sanity check, which is a lifesaver, and then we'll signal the Faucet process to reload and calculate the differences. And that works really well. So if in just this particular conditional, which is just looking at link capacities and saying, well, this one is better right now than this one, that's one thing. But as Kevin was mentioning, there's a little bit more intelligence that we can build in when we take in other data sources, such as inventory systems, such as NMS systems, and actually looking at current throughput as well to see what the saturation is, because it's not just about capacity either. And we can really direct traffic in different ways. So it's just another slide just to show, because I ran plunge again, and if you look back and forth on the capacities, like Kevin was saying, in the wireless world, they change in real time. So having some way of actively looking at this, multiple times over the course of 10 minutes and redirecting things is important. So in this case, one of our capacities went from 160 meg to 195 meg, right? And that's, in the wireless world, on a single link, having that 30 meg capacity difference is kind of a big deal. That's the difference between someone's Netflix working and not working.
What is capacity?
So in this context, capacity, it's no different than like when your phone connects to a Wi-Fi, you're on 802.11g, and it will say linked at 54 meg or linked at some other, it's just I mean, you can probably answer this better than I can, but it's a aggregation of a bunch of stuff.
Yeah, so in microwave radio networks, it's all based on QAM. So we're trying to reach a certain level of QAM to put bits like actually onto the onto the RF. And so the radio is usually some kind of embedded Linux system that is going to calculate, based on this QAM and these other variables, like what are my interference and all that, what is the actual data rate that I can put across this link? And so that's what it's returning
at that
back.
moment.
What is my max data rate without loss, given those RF values?
Does it generate its own traffic, see what the rates are?
I don't know. It depends on the radios that you get into. If you get into the Metro Ethernet world of radio, so companies like Ciclu and SAIE, they're actually using OAM to actually monitor that and return some health values on that. But I don't know they actually run like a health check or a heartbeat to validate that. They're basically taking the data from the radios and then doing a computation on the available health and then looking at the statistics, because there are actual physical layer drops in the radio that it will register. And so if it sees that, it may back down a modulation level to where it's not, not reaching loss or not having a loss ceiling.
If you ask me that question again, I would say, if you ask me that question again after he answered it, I'm just gonna say it's an integer as far as I'm concerned. So that's how that kind of works. We have a lot of plans to, like I said, federate, create a standard of the data. And if I can make a single platform for all these other conditionals, for everything that everyone's doing to feed into Drainpipe, we can come up with a way to standardize how we're calculating the YAML changes and actually put things out there in a way that doesn't step on anybody's toes. This is just a fun little slide. It's nothing to do with anything, but if you're using Faucet, which is very Linuxy, I know Kevin is not very Linuxy. That's all I run. I don't run anything else, but just a quick tip, if you're running something SSH with secure CRT or something, make yourself a button bar so you have one-click access to very common functions, so you're not remembering commands. So I think that's all it is for me. Hand it back to Kevin.
All right, so we're gonna get into prod, so sort of prod. So we were fortunate enough, because we work with a lot of ISPs. Adair Winters, sitting back there in the room, is a good friend of mine. He owns an ISP that is a regional ISP in Amarillo, Texas, serving the people of that community. They've got a mixed ISP doing microwave, doing fiber transfer, GPON, fiber to the home. What are you doing? Cable. I think you're doing pretty much everything that can get packets to somebody in your network. So they serve that area. We've been friends for a long time. And so I came to him with this idea about, I don't know, a couple months ago and say, hey, man, can I beat up your prod network with some stuff? And he's like, yeah, let's do it. So, we took kind of a test section of his network that we'll look at in a second and basically overlaid it with some VLANs onto the prod network to kind of start a test bed that we're still working on. This is definitely still a work in progress. And one of the things that we enjoyed about coming here is, we kind of got to a certain point and learned a lot of things, and then really want to dig into Faucet to see what else that we can do. Where can we take this? And so if we look at, this is what we actually built in prod. So covering 10 miles of territory out into the last mile from the data center. We've got our Zodiac sitting at the towers. And then down, we have Adair's house here 10 miles away, which is where he was our test customer. He was our guinea pig. And we've got a 24 gigahertz unlicensed link up there between KD5 DYP. Ham shout out, because I think that's your call sign. That's the tower. Then we have Osage, which is a location on the way to the data center, going over a licensed Cambium 11 gigahertz link. Then we've got an Ubiquity Networks 5 gigahertz unlicensed link. So that's 5 gigs, same as the Wi-Fi frequencies. We just happen to do a slightly different modulation for the microwave world to put data on it, still Ethernet based. And then we got single mode fiber transport up there. So that's what we put out with the Zodiacs to actually take our OpenVSwitch lab and put it into some measure of prod to test. And so what we found out was, this was something that, we're still working on. We definitely had some success with ACLs and moving that out. But I think moving to layer 3, we could make things a little more intelligent, because we got it to work, but then it would kind of not work. And so I think somebody was talking about debugging the hardware. Who's talking about learning the hardware? You learn the hardware when you do this. You were talking about this. That is an accurate statement, because it was hard. Like the Zodiac boards, I wasn't really clear how to debug that. So when we were in OpenVSwitch, you could very clearly see things like flows and run debug commands, but it was a little harder, at least in the version of the Zodiac we had, to get to the bottom of it. So understanding all of that was a bit of a journey. And so I think, looking back, as we were sitting there trying to figure out okay, it's working and now it's not working. Why is it not working? And debugging this, I think one of the things that we definitely want to look at now is we were able to watch a flow move and see how Faucet manages the traffic and manages the flows, is to actually move it into prod hardware and make it more intelligent. Because I think our biggest challenge in learning this is we only had 2 paths. So we were doing very, very simple calculations that if the path drops over here, if the RF capacity drops over here, just move here. Very, very simple path calculation. But, in his network, we've got, a few hundred points of paths that we have to compare. And I actually looked, somebody was doing, I think, path computational work in relation to either Faucet or OpenFlow or Ryu or something like that, that we're probably going to start diving into and see, can we combine path intelligence, and how do we compute the paths and the available capacity to be able to help solve this problem? And so that's kind of where we're going to take it. But we were able to make the things work, and we were able to move the traffic. So we were very excited about that, being new to the Faucet world. And then I think I already talked about the next steps, but our little joke Drainpipe, that's just our program that we use to feed the stuff into it. I think we definitely want to take that and start getting more intelligent about, how do we do the paths? How do we look at the bandwidth available? And what are the other things that we can do with this? Because one of the biggest challenges for an RF network is when you're dealing with destination-based routing, you have this unused capacity. And if you have maybe 4 or 5 gig of aggregate capacity that's sitting on a backup path, that's a lot of expensive bandwidth that's sitting untapped and unused that, we could be, putting Netflix over or some other streaming media. I think we want to definitely move to BGP because the prod network is BGP based, like a lot of ISPs. So an iBGP AS with OSPF underneath it. So integrating with BGP at certain points as we put a Faucet network in, we want to understand and look at what that looks like. And then getting into prod hardware that has some debugging capabilities so we can understand if we do move this into like full true prod, what does that look like? And so we've already talked to the guys at Allied Telesis, about putting a small hardened switch in at the tower and like actually trying this in the real world and converting part of AW Broadband's network over to put it under SDN control, which I think would be, a really, really fun project to work on. So I think that's one of our next steps. And finally, before I wrap up, I want to thank just the team at Faucet for having us and accepting our talk to come out here, AW Broadband for letting us beat up their network, Google for hosting us, and of course, Nick Baraglio for throwing us on the bus to come here and talk to you guys. And yeah, that's pretty much it. We're kind of at the start of our journey. That's where we're at, and we're definitely looking to diving in more. Yes, sir. So that's something that I think it's probably too early for me to answer that question because we're still learning the distinction between like looking at per route per flow because we haven't even moved into the L3 world. So I think that's something that we're open to, looking at, more than one way to solve that problem because I think, it really understands, what's the cost in hardware, what's the cost of performance, the overhead, the available resources, because I personally don't know how to answer those questions because we're still very new to Faucet. All right. Any other questions? Oh, over there.
Basically, it's a situation where you promise each customer we'll give you like 5 megabits. The problem is that all of a sudden you have a customer problem below the ability to serve them all with the data that they need.
Yes.
And you're doing this by changing.
No, we were just trying, basically, the very simple test was by looking at the source IP, we were just trying to output onto a different path and change the path. So that was the very first step that we took to try to move the path.
What's the path selector?
Well, it was the source IP.
Right. What causes packets?
It was the ACL applied on the input direction for the source of the ingress of traffic to an output port. Yeah, we were changing the output port. Like on the Zodiac, basically, we had 2 different paths. And so path 1 seemed to be what the stack would natively prefer. And so based on the source IP matching on the ACL, we would output to a different port.
And just to tack onto that, when you're talking about subscribers and particular data plans that are sold from a business standpoint, those are systems and software that are external to everything we're talking about that we would like to integrate with and use that data to influence who we move over, not just discriminately move a /26, 25%.
Right.
We can make really intelligent about this customer can move over to this path right now. So.
As far as we used Faucet. I mean, Faucet was the only central control we used.
With the FX, you don't get any secure connectivity. It's
Right.
The
And
FX is really just for proof of concept.
yeah, this
right
was
now.
really just, this
Yeah.
was just kind of an experiment to see with this, could we actually make this work? Because in full prod, I think we've already talked to Allied Telesis that we would do for, you know, because we didn't really have any production subscribers going over this. It was just his house. But, you know, certainly once we put the prod gear in and do have a secure connection to the control plane, back to the controller, you know, we would actually look at moving a section of the ISP under SDN control and move it for real into prod. All right, cool. Oh, another question. For us, it was just very easy to understand the dynamics of the way faucet worked. I think we're probably going to be exploring other ways to move the traffic and what are the different ways we can do this in the future. Because this got us to a state where not having touched faucet, not ever really being involved with it up until 2 months ago, it let us understand how does this thing work? What are the mechanics of it versus coming from a traditional route switch network. But that's something that Nick and I talked about a lot. Is I know that ACL is kind of a, you know, this is kind of a sledgehammer approach, but what are the other ways that we can do this? How can we get more intelligent about this? Do we want to be more granular about the way we move flows, or do we want to be, you know, more up at an aggregate level? And so I think those are all questions that we're going to continue to kick around and look for different ways to do it.
It's also less resistance because faucet seems to abstract a lot of the complexities of understanding how OpenFlow works away from what we want to do, which is the intelligence part of it. So it just makes it a lot easier to get to that end stage.
Okay, yep, over there. Yeah, I think there's actually, I mean, in the radio world, they're already doing software-defined radios for frequencies. I mean, they're already using software to, you know, select a frequency. I would see a very logical extension of that to say that I think you could probably combine the two. And if you know that you're having to change frequencies in software or redeploy it on the fly to be, you know, completely different modulation, that there would be some level of integration you might want for these to talk to each other and share that information.
Okay, thank you very much.
All right, thank you guys, appreciate it.